We're going to take a look at an interesting concept in statistics known as Simpson's paradox. Analysts have to be very careful when reviewing results. There are a number of things that anyone who's doing any type of data analysis should be concerned about. We've briefly spoke about graphs. Graphs can be an issue because if your scale is a little different, it could cause issues in terms of interpretation. Very large scale might not show too many differences, and a very small scale could show differences that are really insignificant. But this one's a little bit different. This is a situation when the wrong conclusion is drawn depending on the analysis. And Simpson's paradox refers to a trend or a result that is reversed when data is aggregated or separated. And it was first described by an analysis from the University of California, Berkeley admissions in 1973. The data shows the bias in admissions of male and female students. If we look at this, we have 41% of all admissions. Male was 44%, female 35%. And in this case, you end up with a situation where people could say, well, it obviously looks like there's a bias in the admissions. But a deeper look at this will show something a little different. Here, when the data is separated by department, something different happens. In the original paper that's listed below, 6 out of the 85 departments were shown to be biased against men and 4 were biased against women. The table below will show the top 6 departments, including 2 biased against men and 2 biased against women. And here you can see Department 1 and Department 2 just had a lot more applications for the male than female, and so therefore the admissions might be a little skewed because there were more females admitted as a percentage there for those 2 departments. For Departments 3 and 5, it was the reverse, even though it was slightly, but it was still significant. So it's important to truly understand that these types of paradoxes and these types of analysis can create certain problems. And it gets to an old adage that Mark Twain said, there's lies, damn lies, and statistics. And another one was, figures don't lie, liars figure. We want to be careful about introducing our own biases or seeing something that we just want to see in our analysis. That is very, very dangerous. So we want to make sure that we're trying to do this with as an unbiased approach as possible.